Okay, so in this case, we've been presented with a hydrocarbon, and we've been told that it's got an empirical formula of C₂H₅, and we've been told the molecular formula as well, 58 grams per mole, and we've been asked, well, based on that, work out what the molecular formula of the hydrocarbon is. Okay, so how would I approach this? Well, what do I know from this question? Well, first of all, I know that the empirical formula is effectively the simplest, and in other words, you can say the smallest whole number ratio of the atoms of each element present in a given compound, right? And the molecular formula is the actual number of atoms of each element present in a given compound, which would be represented in the molecular formula effectively. So we would need to, at least for me, the way I'm going to approach this, I'm gonna first try and figure out, well, what's the molar mass of our empirical formula, and once I do that, I can compare it to the given molar mass of the molecular formula and figure out, well, what's the ratio, and that ratio is going to effectively tell me what the multiplier is, and let me know how to scale it up. So how are we going to do that? So C₂H₅, we've got carbon and we've got hydrogen. I'm going to need to work out the molar mass of the constituent elements in order to work out the molar mass of our empirical formula. So I'm going to use the periodic table for that. So for carbon and hydrogen, okay, so hydrogen and carbon, right? So for carbon, right, we've got 12, a relative atomic mass of 12, and that's effectively our molar mass, right? Wait, I don't know why I circled this. I mean, I intended to circle that, but it's the same difference. So yeah, the relative atomic mass is effectively the molar masses. So I'll put the MR, use the MR symbol for the molar masses. So MR of carbon is equal to 12. Yep. And MR of hydrogen is equal to 1, right? Okay. And okay, so we've got the molar masses, but now we need to actually work out, from that, we need to work out the actual molar mass of the empirical formula. So how am I going to do that? Well, I'll set up a calculation. So I'm going to do C2, okay, so C times 2. So that's going to be effectively molar mass of carbon, so 12, multiplied by the numerical coefficient for the carbon, which is 2. So that's 2. And I'm going to add that to the molar mass of hydrogen, which in this case is 1, right? So, and I'm going to multiply that with the numerical coefficient of the hydrogen, which in this case is 5, right? And so what's that going to give us? So I would invite you to have a go and see what you get when you work this out. But what you should find, if you do work that out, is you should get 29, right? 29. And so therefore the MR, we say the MR of the empirical formula C₂H₅ is equal to 29 grams per mole, right? Okay, so that's the empirical formula. We've got the MR, and if we just do a quick visual comparison, you can see that it's not the same as the molar mass of our molecular formula. So just based on that, without even any further calculations, we know, okay, well this isn't our molecular formula. It's we can reasonably say it's smaller. Basically, it's not got as many carbons or as many hydrogens as what our molecular formula has. So we would need to work out, well, what's the multiplier factor? What do we need to multiply each of these by to get to what the molecular formula is? From visual inspection, you can probably figure out what it is, but to approach this in a bit more of a systematic way, simply put, what I'm going to do is I'm going to take the molar mass of the molecular formula and divide that by the molar mass of the empirical formula. So effectively, if I was to put that as an equation, I would say the multiplier equals the MR for the empirical divided by the MR, and that's just like empirical formula, right? So I'm just using the abbreviation molecular. No, wait, that's the wrong way around. Just let me just clarify that. So that's actually the wrong way around. So MR of actually the, let's just sort this out. MR of the molecular divided by MR of the empirical, right? Yeah. So yeah, that would give us the multiplier. And so what does that mean in practice? In practice, what this means is taking 58, which is the molecular, dividing it by 29, which is the empirical, right? So this is just creating, just kind of putting together a bit of a formula which applies to any given case, even though this one I would say is relatively simple. So therefore, in this case, the multiplier is equal to what we've worked out, which is effectively, no, wait, let's start with the molecular since the molecular is at the top. So 58, right, equals 58 divided by 29, right? And each of these are, as we know, is in grams per mole. Right? And what multiplier do we get? So I'd invite you to have a go. Maybe you already know what the answer is based on just looking at it. But in any case, have a go, figure out what the multiplier is based on that. Okay, and so what you should get is that the multiplier is actually 2, right? So it's 2x. Okay, so we now know what the multiplier is, and we know that we need to apply this to the empirical formula. So what are we going to do? Well, let's start with the carbon. Okay, so for carbon, we know it started off with 2, right? So initially we had C2. We had a numerical coefficient of 2. So we're going to do 2 and we're going to multiply it by the multiplier. So it's going to be 2 times 2, right? Which is going to equal 4, right? And therefore, in this case, what we're going to have is C4, right? So the new numerical coefficient, and effectively the numerical coefficient that we would see represented in molecular form is going to be 4, C4. And now we can do H, yeah? So if we apply the same to H, let's just check quickly what the coefficient for H in the empirical formula. We can see it was a 5, right? So we're going to effectively have, okay, we're going to have 5 multiplied by 2, right? And of course that's going to give us 10, right? And therefore, the numerical coefficient for the hydrogen is going to have H10. Okay, and so if we put those two together, what do we get? Well, we would effectively get C4H10. Okay, so in this particular case, the molecular formula is going to be C4H10. And if you want to, you can have a go at double checking what the molar mass of this actual specific formula is going to be. And if you do that, you would find that it's going to give us the 58, right? But nonetheless, yeah, this would be the molecular formula in this case.